Okay, so today's lesson in gambling is about expected value and fair price, and really, again, those are the same things, just from different perspectives. So I'm going to put that up at the top, that in general, expected value which is what you can expect to win on average from an establishment, is really the same thing as what we would call a fair price, which is from the establishment's point of view, what should they charge to play their game? And when those are the same, then you know it's what they call a fair game. So first example, for those of you who don't know, there's a game called roulette in gambling. Roulette is where there's a wheel, and on the wheel there are 18 red numbers, 18 black numbers, and 2 green numbers, 0 and 00. You put a little ball on it, you spin it one way, you spin the wheel the other way, or vice versa. And then when the ball stops, if you have the number covered that the ball lands in, you win. Otherwise you don't. End of story. So that's what's going on here, and they want to know, is $1 a fair price for playing this game? So what ends up happening is when you're trying to figure out this fair price, what you do is you take the chances and the earnings times each one. So, for example, let's look at 18 red slots. So there's 18 red slots. So the amount of payoff in 18 red slots would be 18 out of however many chances you could have to land on a red slot. So there's 18 red, 18 black, and 2 green, for a total of 38 different slots that your ball could land in. You multiply that by the amount of money that you would get if the ball lands there. So if you land in the red slot, it also tells us you get $2. So we multiply that by 2, because $2 is how much you would get. And then they also talk about the 18 black slots. So there's 18 black slots. And if it lands in the black slot, oopsie, that's an 18 out of 38 chance also. But you only get, do you win if you land on a black slot? No. So you multiply that by $0. So this is $0. This was $2. So in the red is the probability of landing on a red and how much it pays. In the black is the probability of landing on a black and how much it pays. And then you could also possibly land on a green slot. And I'm not going to use green because it doesn't show up so well. But you could land on a green slot, and there's only 2 of those. You don't get any money if you land on it. So there's 2 out of the 38 chances that you land on the green slot, and that's also going to pay out $0. Now when you multiply this all out, you get a certain number. Could you multiply that out for me? And actually the last 2 in the black and the blue, you don't have to worry about multiplying out because anything times 0 is 0. So all you have to do is actually multiply out the red. 0.947. This means that on average, you can expect to win 94.7 cents. They charge $1. Is that fair? No, because they're supposed to be equal. So that means that the casino is making money on you. Not a ton, 5 cents every time you play. But millions of people are playing. So that's a lot of money that they're making on a regular basis. They go a little bit farther. They say, hey, you know, on average, how much money does a casino make after 1,000 bets? So all you have to do in order to figure that out is to find out their profit. To find out their profit, what you do is you take $1 minus the 94.7 cents, and you get $0.053. This is how much they make every single time one person plays. How many times are we supposed to check out? 1,000. So we take that number and we multiply it by 1,000. And you find out that the casino, after 1,000 bets, makes $53. So you just take the number and multiply by how many times it was played. So the big idea is the expected value. We also know this as the fair price. Or in other words, on average, how much money do we expect to win? Now they use some pretty sophisticated symbols for doing this stuff, and I'm just going to kind of explain it and go back and take a look. It looks like this. And it looks really crazy, but here's what's going on. The first thing, the thing, that big E thing, just means the word sum. Or in other words, add up all the things. And then next is usually the winnings or the dollars that they pay out, or the value of winning. So up above, if we look up above, that X thing were the dollar sign things. So this X is talking about the 2, the 0 and the 0. The P is the probability of winning in each particular case. So again, looking up above, those are the things in the parentheses. So if I look at the red parentheses set up above, the X was the $2, the P of X was 18 over 38. In the black, the X was the 0, and the P was the 18 out of 38. In the last set, the light blue, the X was the 0, and the P was the 2 over 38. And the E in front of all this purple stuff is saying add them up, and you can see the plus signs in between. So it's a fancy way of saying find your total likelihood or earnings for your fair price or your expected value. Okay, it's what we already have done. In example number 1, your grandpa gives you a bill from his wallet every year on your birthday. He closes his eyes and just takes out one bill, and that's your gift. On this birthday, you look in the wallet and you see 8 different bills. You see 2 $1 bills. Where are my 2 $1 bills? 3 $5 bills. 2 $10 bills, and 1 $20 bill. And of course, we want the $20 bill. So, what's the expected value? Or in other words, if you do this over and over and over again, what would you think you would be seeing? Let's talk about the 2 $1 bills. If we use the formula from up above, I know that the payout is $1. So I take $1 times what's the chance of getting a $1 bill? A fourth would be a good way to say it. 2/8 is another way to say it. It doesn't really matter. You're going to type these on your calculator anyway. The 8 is how many different bills there are, and there are 2 of the $1. If I look at the 3 $5 bills, the payout is $5, and there are 3 of the 8 bills that are $5 bills. I look at the $10 bills, the payout is $10, and there are only 2 out of the 8 bills that are $10 bills. And then there's a $20 bill, but there's only 1 of them. So I could get that 20, but it's only a 1 in 8 chance. And as you look at each of these colors, each one is the x times the p of x, the payout, and your chances of getting that, or the probability. I put those all together to find out what my total likelihood is in payout. You find out it's roughly $7.13. I think it's actually 0.7 or 7.12 or some 5. Go to the nearest penny. How many people in here know their blood type? Just one?
What?
Blood type. What kind of blood do you have?
A+.
Ooh, A+. He's an A+ student. I love that. What type are you, Fury?
B.
B? Do you know if it's negative, positive?
I think positive.
Positive. Most people are positive for B. I'm a B positive. Daniel, you know yours? No? It's kind of an important thing to know, especially if you ever get into some situation where you need surgery. 45% of the United States population has O. So if I had to guess yours, I'd probably guess O. And what we want to know, as we go along, one person at a time, is what's the likelihood or the probability that it takes until the third person to find somebody that has type O blood. That means I ask Shirley, and she says nope. I ask Mai, she says nope. And I ask Caroline, and she says yes. So that's no, no, yes. Okay? So when you're looking at this, it's important to understand what's going on. You want a no, and then a yes in this case. So if you're trying to figure that out, what you do is you just take the percentages or the probabilities and you multiply them. And we've done this before. This is actually last week on Friday we did this. So this is 0.0, no. So if 45% is a yes, then 55 is a no. So 55% no. And then I want a second one of those, 55% again, no. And then I'm going to be successful and I'm going to find my O positive person, and that's 45%. And since it doesn't matter whether Mai has O blood or not to figure out whether Caroline does, these are independent events, which means we multiply those probabilities together. So you take 0.55 times 0.55 times 0.45, and you find the likelihood that you're going to find somebody with O blood on the third try, exactly. And to maybe 3 decimal places, you find out this is 0.136. Next question, it says, what's the probability that all 3 people, the first 3 that you talk to, have type O? That means you want to be successful every single time you talk to somebody. And if I'm doing that, that means that you want 0.45 times 0.45 times 0.45. So that's a yes, yes, and yes. And when you multiply that all out, that's a 0.091 chance, or roughly a 9.1% chance that that'll happen. So you actually have a better chance of finding just somebody on the third try than you do, of course, all 3 in a row. Questions? Part C. What's the likelihood that you find exactly 1 person in 3 tries? So there are a couple ways that this could happen. You want exactly 1, right? So you could have, in this case, you could have